Hi, we students of Institute of Aeronautical Engineering would like to present our prototype. It's about heart failure prediction using machine learning. The aim and objective of this uh, prototype are to develop a machine learning model to predict future possibility of failure or heart-related diseases by using machine learning algorithms. It will help to determine the risk factor based on data sets which may lead to heart diseases. Coming to the problem definition, according to WHO, that is World Health Organization, every year 12 million deaths over worldwide due to heart disease. This project aims to predict the future heart symptoms, and it this project finds the heart disease by analyzing the data of patient, which classifies whether they have heart disease or not using machine learning algorithms. Heart disease is even highlighted as silent killer, which leads to death of person without obvious symptoms. Coming to the background of the idea, that is, who is it for? People with cardiovascular disease or who are high cardiovascular risk need early detection and management, whether in machine learning model can be a great help. Um, some people like cardiovascular who are highly in risk, cardiovascular risk are hypertension, high BP person, a diabetic patient, hyperlipidemia, and already established disease ones. Background of the idea, what will it do? Heart failure is common event caused by CVDs, that is cardiovascular diseases, and this data set contains 11 features that can be used to predict a possible heart disease. It then processes user specific details to check for various illness that could be associated with it. Here we use some intelligent data mining techniques to guess the most accurate illness that could be associated with patient details. Based on the result, system automatically shows the result, specific doctors, and further treatment. This application allows user to share their heart related issues and predict whether they are in a risk zone or else they are safe. So, coming to the potential markets of this is the proposed system is GUI based, user friendly, scalable, reliable, and expandable system. The model can also serve the purpose of training tool for medical students and will be a soft diagnostic tool available for cardiologists. The proposed working model can also help in reducing treatment costs by providing initial diagnostics in time. Coming to the design and methodology of the prototype, this project is based on a machine learning model, that is decision tree classifiers, where a set of values are taken from users to predict whether he or she might have heart disease or not. And the main libraries used in this project are NumPy, Pandas, Matplotlib, Seaborn, Scikit-learn, Flask, and XGBoost. Let us look what these are. Coming to the rough sketch and design of this, we'll collect the attributes or the information that we are going to collect from the patient are um, the age of the patient, and the whether the person is a male or a female, chest pain type, that is typical angina. Typical angina is nothing but chest pain, typical angina. Coming to typical angina is nothing but emotional stress. And next is atypical angina, that is ATA. It is nothing but when one expresses chest pain that doesn't meet the criteria for angina. Next, coming to the uh, non-anginal pain. It is a recurring pain in your chest. It's typically behind your breastbone and near to your heart. Uh, Next comes the asymptomatic pain. That is the uh, physical indication or a rash or pain or discomfort of disease or a disorders. Next, we are going to take resting BP, that is resting blood sugar in a mmHg. While coming to cholesterol, we are going to take the serum of cholesterol, that is in a mm by dl. Coming to fasting blood sugar and resting ECG. Uh, uh, Max HR and exercise angina, old peaks of ST slope. Here ST slope is nothing but it's a wave ST and T wave, which may represent cardiac pathology to be normal variant and the range of it, and heart disease. This is a example model of the prototype. Let me show you the prototype that we have made. This is a front-end design of our prototype heart failure prediction using machine learning and its prototype. Age, we are going to give all the attributes and find after submitting, you will get the predicted value. And this is about details about this portion is about the details of the heart failure, and these are the contact details. When you click here, home, you'll visit the home page. While coming to about, you can visit the place where details of heart failure and some description about heart failure is found. And when you click on prediction, you will be taken to a place where you need to enter the values and the pain through which you are going, and submit those details, and you will find the output. It is just a front end design, and coming to contacts, you'll find the contact details. It's just a front end design, doesn't have any back end, so we are unable to show you the outputs in this web page. While coming to the back end design of this, this is the another web page that we have made in which is linked to the data set, and you can even get the values, predicted values. Suppose if age is 40 and the check is male, coming to the chest pain, typical angina, and resting BP is 120 and cholesterol is 40, approximately 40. But fasting blood sugar is 38. Resting electrocardiogram result maybe like have uh, S, uh, S, ST and T wave abnormality. Max heart rate as a 80. Old peak depression as a 0.5. And let's predict now. You can find the probability of the data we have entered, and the value it is showing as 74.5. That is, we are at almost near to the risk, and it's better to visit a or consult a doctor. Here you can see its heart failure probability value is 74.5476. It's a precision. And this is all about our prototype. And coming to the conclusion, there are many possible improvements that could be explored to improve the scalability and accuracy of this prediction system. The performance of the health diagnosis can be improved significantly by handling numerous class labels in prediction process, and it can be another positive direction of research. As we have developed a generalized system, in future we can use this system for analysis of different data sets also. These are the references which we have considered to make this project. And thank you. So I can say that this by visiting this web page, you can conclude that whether to visit the doctor or not. If the value probability value is approximately 0, then you are less prone to the heart disease. It might be due to some issues like gas trouble or some other thing. If it is more than 0, then it's better to consult the doctor and get the medication as soon as possible. And thank you. This model helps the patient to reach or consult the doctor as soon as possible, and to get the medication and know whether he is suffering from the heart related disease or not. Thank you for giving us this opportunity.